In this video, we're going to look at a couple more examples of solving systems of equations with two variables. We're looking at linear equations. Sometimes you'll be asked to solve a system of equations by the method of your choice. That means you're either going to be using substitution or the addition method. Okay, so when you look at the system that you're provided with, you have to determine which one would be best for you to solve. Now, my kind of general rule of thumb is that if I have something that's easily rewritten as y equals something or x equals something, I like to use substitution. If I have something that's already in, where both of them are in the ax plus by equals c standard form, I then like to use the addition method or elimination method. So in this case, I might actually choose, even though these are both written in standard form, I might choose to use substitution to solve this one because I can easily solve the first equation here for y, because I have 2x plus y equals 2. If I subtract 2x from both sides, I end up getting y equals 2 minus 2x. So it was very easy for me to rewrite as a y equals, the first equation as a y equals equation, and so therefore I might use substitution in this problem. So what that means is in the second equation, I can replace y with 2 minus 2x. So the second equation is 5x plus 3, and instead of y, we're going to write 2 minus 2x equals 9. I'm going to distribute out the 3 to the parentheses. So I have 5x plus 3, plus 6 minus 6x equals 9. I have 5x minus 6x, which gives me negative x plus 6 equals 9. Subtract 6 from both sides, because at this point we're solving for x. Subtract 6 from both sides, and I get negative x equals 3. Divide both sides by negative 1, and I get x equals negative 3. Now that I've solved for x, I can go back into the first equation, replace the x with negative 3. So I have 2 times negative 3 plus y equals 2, and solve for my y value. Remember, we're solving a system of equations means that we're looking for a coordinate pair that satisfies both equations. We need an x-coordinate and a y-coordinate when we're dealing with two variables. So now I have negative 6 plus y equals 2. Add 6 to both sides, and I get y equals 8. So my coordinate pair is negative 3, 8. That is the solution to the system of equations. Here's the cool thing about systems of equations. You can check to make sure that this worked, that you got the correct answer. So let me show you how to check your answer. I'm going to erase all the other work, and I'll show you how to check. To check your work, you take the x and y coordinate and substitute it into each equation, like we saw in the first video. So I would say 2 times negative 3 plus 8, does that equal 2? And I would also do it for the second equation. 5 times negative 3 plus 3 times 8, does that equal 9? And I would solve both sides, or the left-hand side of each of these equations, to determine whether or not they make a true statement. So I get negative 6 plus 8, does that equal 2? Negative 6 plus 8 is equal to 2. 2 equals 2, check. It worked in the first equation. Now we check on the second equation. 5 times negative 3 is negative 15, plus 3 times 8, which is positive 24. Does that equal 9? Negative 15 plus 24 is equal to 9. 9 equals 9. Check. This works. So we have checked both equations, and this coordinate pair is our solution. In this next example, number 6, again, we get to choose the method that we want to use. Now, this one's interesting because the first equation, 5x equals 4y plus 6, I could divide both sides by 5, and I would end up solving for x equals. And then I could use that to solve the system with substitution. But if I divide both sides by 5, I would end up with x equals 4/5 y plus 6/5, which is not a very nice equation due to those fractions. Also, if you think about it, I'd be plugging or substituting in this fraction into here, and it's not going to cancel nicely, okay? Now, the addition method is likely still going to give us fractions, but it might actually be a little bit nicer to deal with, okay? So I'm going to actually take my first equation, 5x equals 4y plus 6, and I'm going to move that 4y over to the left-hand side. So I subtract 4y from both sides, so I end up having 5x minus 4y equals 6. And then the other equation is negative 3x plus 7y equals 1. And I have to figure out which equation or which variable I want to eliminate or cancel. I'm going to try canceling my x variables. It doesn't matter. I could have also done my y because in this situation, we have opposite signs on our coefficients, and I'm going to have to multiply both equations. Okay, but in this case, I'm just using my x's just because I have a factor or a multiple of 5, and it's a little bit nicer to look at. It wouldn't matter though, you could do the same thing with your y's. So in order to get the x coefficients to be exact opposites of one another, I'm going to have to multiply the first equation, the entire equation, by 3, and I'm going to have to multiply the second equation by 5. I'm going to kind of show my work and what results over to the left, because this is going to multiply everything by everything in the equation or in the parentheses, and same thing here. So we end up getting 15x minus 12y equals 18. And then on the second equation, we get negative 15x plus 35y equals 5. And now do you see our coefficients for our x variables are opposites of one another. So when I add these two equations together, 15x plus negative 15x gives me 0x. It canceled or was eliminated. Then I have negative 12y plus 35y, which gives me 23y. And I have 18 plus 5, which gives me 23. Divide both sides by 23, and I get that y equals 1. Okay, so here's what's nice about this. By using elimination, I didn't get all the complicated fractions that I would have gotten if I had used substitution on this one. So, and remember, I'm only halfway done though, because I've solved for my y. Now I need to solve for x. So I get to pick out of the two original equations. Let's not use the multiplied ones. Let's use the original equations. I get to pick which one I'm going to solve for x on. I'm going to erase to clear up some space. I'm going to substitute in my y value, y is equal to 1, into the first equation. So we have 5x equals 4 times 1 plus 6. So then I get 5x equals 4 plus 6. 5x equals 10. Divide both sides by 5 to solve for x. And I get that x equals 2. So my coordinate pair is 2, 1. And then you can use the method that we showed earlier to check your answer. I'm going to do this example that has fractions in it. Fun times. We love fractions. There's kind of two ways you could think about this. One is you could clear out the fractions. The way you clear out a fraction on an equation is you would multiply everything by the least common multiple of the coefficients. Or sorry, the least common denominator of the coefficients. So in the first equation, we have a coefficient of 1 on the x, a coefficient of 5/3 on the y, and a constant of 1/3 on the right-hand side of the equation. And so the least common denominator between a 3 and a 3 is just 3. So we can multiply 3 times that first equation. We can also do the same thing on the second equation. The least common denominator of the fractions listed there is 2. So I'm going to multiply my first equation by 3. So I'm going to end up with 3x plus 5y equals 1. Because when you multiply 3 times 5/3, you get 5. And when you multiply 3 times 1/3, you get 1. 3 1/3 equals 1 whole. Okay. We're going to do the same thing here. 2 times 3/2 x is going to equal 3x. And then 2 times 5/2 y is going to equal 5y. And then 2 times 2 equals 4. Now, I can look and see right now I can use elimination, but something funny is about to happen. If I look at my coefficients on x, I have a 3 as a coefficient for both of the x terms in both of these equations. And so what I could do is I could either multiply the second equation by -1 to have it be opposites, or instead of doing adding the two equations together, I could subtract the two equations. So either multiply the second equation by -1 or subtract. It's going to have the same impact, because then I think of this as 3x minus 3x, which equals 0. It cancels. And then 5y minus 5y, which equals 0. It cancels. And then 1 minus 4, which is -3. So I end up getting x equals -3. This is false. This is not a true statement. So that means that there is no solution to the system of equations. Remember, we talked about in the first video the 3 situations you might see. This is an example where I would get no solution, since 0 will never be equal to -3. If, when you solved, you had gotten something that was very, very, very obviously true, like 1 equals 1, which is always true, that's when you end up having infinitely many solutions. Okay, but since we got something that was completely false, 0 does not equal -3, that is false, we end up having no solution to the system of equations. I'm going to go ahead and do an example of an application of solving a system of linear equations. We have a textbook store sold a combined total of 274 psychology and sociology textbooks in a week. The number of sociology textbooks sold was 66 less than the number of psychology books sold. How many textbooks of each type were sold? So the first thing I want to do is take this first sentence. We're told that there's a total of 274 psychology and sociology books that were sold in a week. So psychology plus sociology books equals 274. That is our first equation. The number of sociology books was 66 less than the number of psychology books. So sociology books equals the number of psychology books, taking away 66 of those. Okay, so now I can have my two equations in my system. I'm going to solve them. This one I should solve using substitution because we have S equals P minus 66. So in my first equation, I have P plus S, which is the same thing as P minus 66, equals 274. I'm going to combine my like terms. P plus P is 2P minus 66 equals 274. Add 66 to both sides. We end up getting that 2P equals 340. So divide both sides by 2, and we get P equals 170 textbooks. Now, if I've solved for the number of psychology textbooks, now we're going to go back into one of our equations. I'm going to suggest this one to solve for the sociology textbooks. So we know that sociology textbooks equals the psychology textbooks minus 66. So that's going to be 170 minus 66. 170 minus 66 gives us 104. So there are 170 psychology textbooks and there are 104 sociology textbooks. How could I check my work? Well, one thing I could do is say, okay, well, psychology plus sociology books must sum to 274. So if I do 170 plus 104, I get 274. That's one way I could check my answer. Okay, so this is just an example of how we solve a system of equations in an application problem. There are several more examples you can try on your own, and then if you have any questions, well, there's one more that you can try on your own, but if you have any additional questions, you can contact me via email, and I will help you out during my office hours. Thank you so much. Bye.